What do I do to start? What do I do to start? I mean, I was working on some stuff today. We could pick up from there. Okay, so we're going to need another shell probably. Oh, we got to be on D drive because this computer. Okay. I don't know what to do with this one yet. Okay. So, let's exit this one for now. Okay. I want to make this loop. We got a communication system here that I did earlier. This is sort of the user level part of it. There's about 500 or 600 lines of other stuff, and it sets up a shared memory channel, and these guys read and write from it. Why? Because that's way faster than using a pipe or whatever, because you don't have to go through the kernel, which is great. So if you're going to connect to something on the same machine and you want to send it data, this is just the best way to do it, by far. I have not done the Linux port of this yet. Which we could do as well. But I want to at least get the client and server. Okay, so this stream is labeled Cool Weekend Project, and the Cool Weekend Project is going to be to build out a new piece of our program visualizer that we haven't done before. But tonight is going to be all preparatory stuff, so I want to get this running better so that it's we can actually like crank messages in a loop. I want to finish this example so that you know, it like maybe sends a bunch of messages and then benchmarks or something. Anyway, we'll see how it goes. We will see how it goes. So, we're going to start by making this loop. What I had previously done on the plane yesterday and then today during the day was I just set these things up so that this guy can put messages or a limited number of messages into some buffer for this guy to read. This is going to fail. This guy doesn't wrap correctly yet. We haven't tested that. Our channel is this big, so let's just make a loop. The loop is going to keep sending hello sailor over and over for now. This guy exits as soon as he reaches the first one. Let's do this. N is 10 for 1 to n. On the last iteration, we say goodbye. And we're just going to hard code the reader. Okay, so the way this works, it's an asynchronous communication system where you reserve some amount of memory, and we figure out where it's going to go, and we give you back the pointer, and then you just do whatever you need to do to compute the message you're going to compute into that region. Or, See here, we're gonna actually fill this up if we try to go real fast, and so we're gonna have to figure out what our policy here is. We're gonna need to like count the number of fails in a row, etc. Okay, so maybe just skip frames. All right. So we say that we reserved a message, we copy the string data, we commit the message, and as soon as we commit the message, it means it could be read. This means the contents of the message are all complete, so it's okay for the reader to see the message. Okay. And then we're just going to sleep for 10 milliseconds every time right now. Now on the reader, we're going to say if s is equal to goodbye, we break. Okay, otherwise we keep going. All right. Now let me rebuild the compiler. It's been a while since we have done that. On this machine, at least. I mean, I was building it a lot today, but on this machine. On this machine. All right. So, stop. We'll compile this. Read. That worked. That worked. Wow. Okay, so I'm going to go read. So this is waiting for messages. I'm going to go write. And we wrote all our messages and we read all our messages. And then we finished. 60% of the time it works the first time. You know what I'm saying? Do you know what I'm saying? Now, in a real program, we would have some user level protocol that like does some things. Here we do not have that. Here we simply do strings. I mean, it is a user level protocol that says goodbye is the end of the thing. Okay. This is just printing out the data structure. Not particularly helpful. We could even just take that out. Okay, so now I think we're going to make it a little bit more stress testy so we can run in a loop. And we're going to keep it to 10 for a minute. Let's just, we're going to comment this old thing out. So we're going to go, going to get a random number generator. Random get mod, I don't know, 1000 plus 2, 1 byte for message or done, 1 byte for the checksum. All right. So let's call that header size. We got a number of bytes. Number of bytes. Okay. Okay. I guess I'll make an enum. Done is going to be 0 and message is going to be 1. Is there a message here or are we done? All right, once we get down here, oh, this is a little bit annoying. Because you can't, like, interesting. Because we need to actually, like, we don't know that there's a byte left. Okay, so we could fail there. If we don't fail, we say done. We say writer commit message channel message, and then we quit out. Okay. Okay. I have missed some things. Writer reserve message. Num bytes. Okay. S.data. Yes. Okay. So this message. Okay. do it this way. That way num data bytes is like how many things that we want to do. Hold on, let's do this first. Equals protocol tag dot message. Checksum. U is cast U8, random get mod 256. Well, right. So we write the message. Is this really better than writing strings like we did? I kind of don't feel like it is, except that this is going to help us know better that it's correct, I guess. Protocol tag needs to be up here. This message bytes is not a thing anymore. Okay. So now the read loop. See, this is just a lot less readable than saying hello sailor a bunch of times. Do you know what I mean? Do you know what I mean about that? Since we just started this, are there any questions about what I'm doing that are good? Any good questions about what I'm doing? Okay. So, what does this mean? See, normally I would go over here and do this. It's just, Is this a single weekend project? No, I mean, it's part of a much bigger thing. It'll be ongoing for a long time, but the weekend project is to get it to a certain stage where we have good success. For, like, we will have achieved something good. Yeah, I'm on the precipice here. I'm like, I don't necessarily like the simplicity of the Hello Sailor was very appealing. But I think we do want a loop. We do want to have a termination condition, although we did do that. With simpler code. I don't know. This is a little bit more, it's a little bit more like what you would actually do than Hello Sailor, so maybe it's fine. All right, especially after we comment it. So, 50 months. That's almost as old as I am. Oh my God. $50, that's crazy. Crazy. Okay. The web, of course, works very well. We all know this. All right, so here again, we say reader poll for message still. If there's success, instead of this, we're going to say, we know, let's copy this over. We know messages must be at least 1 byte. If we get a 0-byte message, that is bad. If user read bytes, if bytes is equal to 0, if we get a 1-byte message and it is not protocol tag.done, that is bad. I reordered the checks here to make it a bit simpler. Okay, so we're going to do this. If bytes is greater than or equal to 2, I'm trying not to be in compiler author road sign speak, but it's such a habit. If bytes is equal to 1, if value, or let's say command is message.userData pointer 0, right? If command is cast u8 protocol tag dot done log received done breaking from the loop break, okay. It could mean there's just no message ready yet. Okay, so got a message that is too short. Okay, if we have 2 or more bytes, then got an invalid command on a data message. Okay. So checksum is this. Let's say stored checksum from the message is this. My checksum is a U8. And we're going to give 0 to data bytes minus 1. My checksum XOR equals message.user. What is it called? User read pointer. What did we call this variable here? Let's do this here. Okay. Header size, header size, header size. Okay. So if my checksum is not equal to stored checksum, log error, checksum mismatch in message number, whatever, wanted, whatever, got, whatever, quitting. Okay, it is the message index. It's pretty bad style carrying it this far, but we're doing it. Wanted, stored, checksum, my checksum return, okay. I don't know. Yeah, it's user read pointer. Under protocol data, what? Oh. Message index. Let's do this. +1. All right. Has successfully received whatever messages. Coriapted. Nutella. Dude, why did I keep typing that? All right. So we're going to go read. We're going to go write. Ooh. Ooh. We asserted on the right side. And we printed out Garbo strings. And died. Oh, because you know what? We're not printing the... Oh, I don't know. Let's see. The assertion might be that we read too far, by the way. Let's take this part out. We're printing Garbo. Greta Garbo. Okay. This is one of those interesting times where it's like, this didn't seem that hard, but I goofed. It's like, we didn't really notice anything weird. We just maybe read to the wrong place, and on the next time around, we screwed up, which might mean a bug in this code. It might mean a bug in our lower level code. I am not sure. I sort of said the same thing twice. It might be a bug in this new loop. It might not. I sort of don't see how it could be a bug in this new loop. But it didn't do this on the Hello Sailors, so I kind of wonder what's different now. All right. Okay, right cursor of -247. What? What? How did we get -80 as the length? That's not good. That's not good. So on the right end, yeah, and we're getting the -80 here. So we're sending a -80 all of a sudden. And I don't think that's... I keep compiling the wrong thing. There's too many programs. Start the reader. Nope. We are definitely picking. Oh, because we're saying mod 1000, guys. This is the dangers of life. Maybe that shouldn't be signed. Okay, so now this is weird because the reader... wrote. Right. Okay. Now this is weird. Maybe this is failing because the reader is like quitting. It's getting all the messages. It's checking the checksums. The checksums are correct. Where is this assertion? 194. I'm kind of hungry. Oh, we wrapped around the message. Now that's weird. We shouldn't have wrapped around the message. That is, we set this incorrectly. So part of the design of this thing that I'm doing is that the buffer is large compared to the individual messages. So it's a ring buffer, but the messages don't actually wrap in the ring buffer. And what that means is that you can have user level code. I sort of have this on the list of things to comment. You can have user level code that you know, doesn't have to worry about wrapping, which is great. And also you don't have to play weird virtual memory tricks to do that. Okay. Wow, I'm going to need some more powerful caffeine maybe. I got off a plane last night at very late in the morning, and then I tried to go to bed, and somehow the jet-lagged hours sort of prevented me from going to bed. It was a problem. It was a problem. Okay, what are we doing wrong here? These little message reserveds that I'm printing out look correct, but we are wrapping the right cursor there, which is weird. Why are we doing that? It must have to do with our 1 byte done reservation, which is weird because we get the done reservation. Let's see. Okay. Where is this one? That's like in the thing. Who is printing this? Wait, what? Oh. It's here. Ah. Okay. We got here. We somehow see, this is weird. I don't understand how we supposedly... There must be just a super bug. A super bug. Let's get the super debugger. Oh my God, guys. I might have to take a nap and resume this stream in a little while tonight. Because I want you to have the high quality stream, but I am yawning up a storm. Okay, what are we even looking at? Modules. Shared memory. Channel. Examples. Right. There we go. So now I want to break here. Okay, module line 182. All right. Wait, really? Oh, because read's not running. Okay. So our reader, once again, it read all the messages and quit. So I am confused about this. If it read all the messages and quit, what are we going one more time past our maximum message? What? What? What happened? Why did it quit? It should have only quit with a 1 byte message. Oh, we're while wanting, guys. Oh. Okay. We forgot one word. You know, it's like when you forget one word talking to your girlfriend. And she just placed a lot of importance on whatever word that was. There we go. There we go. So we were just spamming the whole buffer with the messages, which is why we eventually wrapped it, because we were spamming it with 1 byte messages. Now wrapping doesn't work yet, but we're going to take the W here, and then we're going to make wrapping work. You're on board with the nap break? Yeah. I might have to nap break. And then I won't be able to sleep, right? And I'll be back in like 45 minutes. But we're not going to do that yet. We're going to keep pushing onward. Let me get a food for a second. Got a high calorie banana food. Good stuff. Seriously, any questions with what's going on? Nobody cares? Nobody cares. Okay. See, we're asserting here when we decide to wrap the buffer, which means if we go to our write program and we say n is 10,000, we're going to die. I mean, it'll take a while because the console is so goddamn slow. But there you go. The buffer size is 65536, and we wrapped it right here. What is this project about? I do not answer that kind of question, because if I did that, I would be saying the same thing all day every time someone asks. You can look backward in the video. What's the behavior what we want when we run out of buffer space? That is a good question. I think that's application specific. And we would like to give people the flexibility to do at least one of two things. One thing might be you're trying to write a bunch of streaming data and all of it is needed to like make sense of the later data or whatever, right? And then you just want to block for a while, kind of like you would when sending TCP, right? And we just want to make sure people can do that in a useful way. Right now, we're punting that to user level. So right now, if you try to send a message and there's no room, we actually just return false from the message reserve function, and you have to wait. Now, on the other hand, maybe you're sending like data every frame, like our initial application for this that we're going to do over the weekend is a frame by frame thing and doesn't really require intermediate frames in order to make sense. So in that case, if there's not enough room, you probably just drop a frame. Right, that's a sign the reader is not keeping up with the writer, and you just don't do anything. And we'll just see. We'll see if there's anything else we need to think about. You know, these little example programs are implementing all that themselves, right? So like, you know, we do the thing. Okay, so I'm actually not going to do this because the Windows console is so slow. So if I get rid of that, okay, there we go. Boom. Now you notice the reader is never crashing. And the reason why is because we're totally transactional about these messages. They don't get sent unless they're done. So, you know, when we crash in the middle of figuring out a message, the reader just got the ones that it got, and it never got the done message. All right, so it hopefully shouldn't be that hard to do the wrapping. The problem is we need to do it on both. So if we write the wrapping sentinel, well, this is the position. We have to decide what is a marker that tells us all our length stamps are non-negative numbers. So our wrapping sentinel, it's just a number. I don't know why I'm saying sentinel, it's just what we're calling it. Our wrapping sentinel being negative means it will not be mistaken for a length. Also, I mean, not be mistaken is very loose language, but guys, I got hungry all of a sudden. I want more than the banana I just ate. Also what? However, just being boring and writing -1 is not good, since that is a fill pattern others might use, so we make a negative number that is unlikely to be used elsewhere. Okay. So we're going to move this comment. Dest is dest is data plus right wrapping sentinel at. Dest is wrapping sentinel. Okay. What is that? If you see this wrap, I mean, must be negative. Okay. So we write out the wrapping sentinel. I'm going to get a little more snack and I'll be back in a second. I'm thinking ahead to when the reader does this, because the reader is going to look at this and say, hey, I should wrap. If this is at the very beginning of the buffer, we might infinite loop. So we're going to assert that we don't write it here. Sus Kool-Aid. Is the Kool-Aid man in Among Us in an expansion pack or something? Is Kool-Aid man like Mr. Potato Person now? Or is he still Kool-Aid man? Okay. Wait. What is data? Data is the pointer to the... Okay. Now there's an additional complication, which is that if we got very close to the end of the buffer, we may not have room to write this. But in that case, the reader knows that because it could see that we're near the end of the buffer, and it just knows to wrap anyway, right? So we're just going to say if header.data size in bytes is less than or equal, is greater than or equal to per message overhead size if there are fewer bytes left on this, the reader will just know to wrap. Okay, so there we go. Okay, we're really gonna want to comment this up real good. Now the reader may be okay. Let's just recompile it. I don't think we had any changes that affected that, but... Uh-oh. We got a parse error. Okay. So... the read cursor stopped at 65563, which I think is valid. Because I think that's additional to the header. I think we have 64K of actual data bytes. Now, why are we printing this? I thought we only print this when we wrap. Okay. So we're printing this out. Oh, no, this is just for the second pass, so this is fine. This is fine. So what's happening is the reader invalid magic number in reader pull for message. Okay, so maybe we didn't. Reader poll. Okay, so when we say done with message, this is when we advance the read cursor. Oh, we're not looking for the sentinel now. We forgot that part. We forgot that part. Now that said, we should have seen a negative length. Oh no, it's a magic number. We should have seen invalid magic number. Because that's the first thing. We didn't see invalid magic number. Oh no, we did see, sorry, we did see invalid magic number. Duh. Remember, see this comment right here, incomplete. It could be the wrap marker. If I would just look at the glowing green text that is trying to tell me what the problem is, this is inserted by the special Emacs AI that knows all about the GitHub Guardians of the Galaxy system. Okay. If magic is equal to wrapping sentinel, it's time to wrap. I hope we are not at the beginning of the buffer though. If read cursor is equal to header.offset to message data log error, we got a wrapping in reader poll for message. I don't know what my convention is about it. We got a wrapping sentinel at the start of the buffer, which is invalid. We must stop. Okay, and then we're gonna do this. Boom. Okay, otherwise, this thing filled up again. Dang it, invalid magic number. I should say what the magic number is. Zero. Invalid magic number 0. So let's just do the bytes remaining. N minus read cursor. All right. Bytes remaining 229. Let's just put this. I don't think these are in the same address space, right? No. So we just have to leave it an offset. So at offset whatever, Oops. So, oh, we didn't ever do it. Well, no wonder. Wait, it offset 0. Oh, I got them backwards. I got them backwards. Okay, now, that's all fine. We are not writing the stamp. We're not tramping the stamp, guys. You've got to tramp the stamp. Because we said this when we tramp the stamp. Let's see about that. Dang it. Why did I do that? Oh, I never compiled, guys. I never compiled since we put that in, so it might actually work. Oh, nope. Nope, does not actually work. Okay. So delta minus 27. So our delta computation is data size in bytes. Yeah. Plus. See. The right cursor is. This offset to message data, by the way, is not what we should be doing. Dang it. I still, what? Oh, I deleted the delta, huh? Okay. Writing wrapping sentinel at 65563. Okay. That seems fine. Invalid magic number 0 at offset 65563. What? 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 Header. Okay, wait. User read pointer. Data plus read cursor. Fuck, this is so wrong. How is any of this shit right? data. Get data area. That's fucking wrong. This is all wrong. How? Oh my God. Okay. Okay. Here, okay. I have, it is wrong because we're doing it wrong on both sides. And so it appears to work. Guys, I have a conundrum here. I have a conundrum. And the conundrum is as follows. One of the things that annoys the shit out of me in like file format definitions, which this sort of is, it's a memory protocol definition, but same kind of thing, is like, hey, in this slot, there's like some byte address or offset. What is it the offset from? Well, from itself or from some different fucking thing. And there's like 20,000 different places that you get the offset from. Here, I decided to offset absolutely everything from the beginning of the buffer, regardless of what it is or where. And intuitively, I keep trying to back that out for this one thing, because the actual data area where your stuff goes, like it's kind of intuitive to wrap your cursors to 0 and whatever. No. I'm gonna do it this way. This get data area is gonna go away. I don't want to see it. Took Emacs that fucking long to unhighlight everything. Data start is get data area header. Yeah. Bro, that was never gonna work. Oh, we're wrapping multiple times, which means we're reading multiple times. Wow, how many are we doing? I mean, 100,000. Is that how many messages? We should actually offset the random number by the timer. 10,000. Only 10,000. Oh, but we keep frickin' sleeping and what? Oh, we sleep 10 milliseconds between every one. Let's not do that. Okay. We're going to leave this incomplete here. We're going to sleep a little bit if we can't reserve a buffer. Okay, we finally got through. Oh no, I Control-C'd it. That's what happened. All right. We want to go faster than that. There we go. Okay, we filled it up. Is the reader sleeping every time? We got a new assertion. So this is weird because this is, oh, this is every time we're less than the read cursor. Let's take that one out because it's just confusing me. Dude. Okay. So assert right cursor is less than read cursor if, really? Seems kind of weird if that race happened to us, but you know what, maybe. Probably wasn't the problem. We do sure seem to be real slow, but okay, we're sleeping every time here. We will only sleep if there was not anything ready. Because when you sleep in Windows, it's like it's not very controlled. Like you can't really sleep for 1 millisecond. All right, there we go. Reader has successfully received 9,883 messages. That's not good. That is not good. That is not good. That is not good. That is not good. 98% success rate. It is better than the World Wide Web. Everybody, we are already better than the World Wide Web. Okay. Why are we only getting 9,883 messages? Because we're continuing in our writer, probably. Like here, yeah, see this? This is incrementing n if we have to wait on the reader. So, boom. Boom. Okay. Now, that's pretty good. Let's, I don't think there's a way. So we're going to do this. Seed the random number generator based on the time to get a new to get a different run every time. Random seed get current time monotonic dot low. Okay, so these last numbers, these should come out differently. 017 437 706. They are. That's great. And we got 10,000 messages. Now, that is still awfully slow for what we are doing. So we will want to look into speed later, probably. Like we might be sleeping a lot still. Let's do one last check for weird sleeps. Like that one's fine. Yeah, we, in theory, only sleep when there's nothing to do. Oh, but we're also, you know, these are debug builds and stuff. Let's actually... fuck. Dude, I wish Emacs were better. I really do. All right. So... we're going to build these in release build. Just making sure that that was good. Bro. Why are we down to 98,000 messages again? What? What? 10,000. I wonder if we have to be more strict about atomic something or other. 10,000. Was I somehow running an old binary? I don't feel like I was. I really don't. I don't see how I could have been. recompile both of them in release. Was that the same 98 number? I wouldn't expect it to be so. You know, I do have problems on Windows sometimes where I swear somehow it runs an old cached binary. Like, it's probably a bug in the program, but like, I swear that's happened to me sometimes. Where I'm like 3 binaries later, but it gives me an old one. This time it's 90. I don't think it's 98,000. Oh, it is. Oh. How is it 98,000? That might be something weird in the reader. That is definitely our bug then. That's not an executable. That... I mean, in theory, we don't spin on this in any way. That's pretty weird. I am bothered by this. I am bothered by this. I'm also bothered by how slow this is. Like, I think we're making some kind of mistake that we shouldn't. Like, both dudes are hammering on the same cache line somehow, even though that's not supposed to happen. Should have printed the seed. Well, I don't think that would necessarily repro it anyway, because it is now a distributed system with, like, it depends on when the reader happens to decide to read relative to the writer, you know, which is not like, you know, reproducing the seed is not sufficient to reproduce that. You would have to like put your operating system in some kind of deterministic mode. Okay, well, that is a little worrisome because that is going to come back to bite me a little bit later. But we got step 1 mostly done. The bug wasn't dependent on the random message size. Well, it might be. We don't know. We don't know if it was dependent on the random message size or not. Is the reader hand in the case where there's not enough space in the buffer to write the sentinel? Should be. So here is where we decide to wrap when we finish reading a message. We say We add the length of the message. And here's the end of the thing, which is, you know, from the header, you go the offset to the message data plus the data size in bytes, all right? And if that is less than the 16 bytes that we need, we say should wrap, and we do it. Oh, you know what? I think these disagree. I think we might have done it on 8 bytes in the other one, which I don't think matters. But maybe if you then happen to have a really short, let's make it agree. Hold on. So if the offset to message data plus the size in bytes minus the right cursor, oh, nope. We write the sentinel if and only if it is greater than or equal to the message overhead size. Right? Now, there might be something weird about wrapping here versus somewhere else. But I don't know. It's hard for me to imagine why. Let's get rid of this should wrap. And let's do this. I mean, it sure looks like they're doing it. We don't even need this. Oh. Let's put this down here. Oh, nope, we needed it up here. Never mind. Never mind. I didn't mean that. Okay, well, what I can do at least is we can duplicate, like if we run this, you know what? Let's use a new feature. Actually, no, we can just use a load for this. Just going to put this here. Boom. Okay, let's put that in source control. I didn't change it. number of messages. And the reason I did that is so that here and that way, if it fails in tests and stuff, we're gonna have to make it run in tests, but if it fails in tests, we'll get an indicator of that. Anyway, change the constant names. That is good advice. Okay. Because I'm on so much jet lag and lack of sleep last night, I'm probably going to take a nap for a little bit and not be able to sleep and then come back and stream some more. But before I do that, any questions about what we did here and or why and or how and or when? So we're going to have to document those examples a little bit more. But that's no big deal. And then we could come back later and actually use this for a thing. Now what I'm going to want to do, so, you know, we have this memory debugger that tells people about memory leaks. But in order to tell you about memory leaks, it tracks how much memory is allocated by what stack trace, right? So when we say, hey, we're going to check this allocation, we say add allocation to table, right? And we say, all right, let's look in the address table, see if we have something, right? And we fill out this allocation. And then we maybe, if it's a new stack trace, we pack it. Otherwise, we find an index to it because you don't want to save a billion stack traces all over the place. Okay, so we've just got this hash table with a bunch of these tightly packed structures. Like we could just copy that shit out once in a while, right? You know what I'm saying? Copy that shit where? Into this buffer connection that we just had that will talk to our visualizer program that will show us the memory usage of our program live. That is the plan. So the plan is, remember this nifty program. So this nifty program has these settings on the side. And right now, it's just for static information about the program. But there's no reason we can't also add dynamic information on extra little buttons down here. So we have a button that says memory use. And if you go there, it shows you the memory use of the live running program. And then everyone will be able to use that because it'll be in the standard thing. And then we can also use it on the Sokoban game. And, you know, drawing the memory use will be very, it'll be very simplistic in the beginning, right? Because you just have like a bar by allocator and like how much is in each allocator, right? You could have amount of memory in one bar and then number of allocations per frame in another bar. And assign a color to each allocator. And then you could probably sort by some things. I don't know. We'll see how it goes. Now you see how the value will be delivered to the people. Yes, the value will be delivered to the people. It'll be great. I've spoken before about the insanity of LSP requiring JSON messages sent over the network to communicate with programs. Is a technique like this a better alternative? It is certainly a better alternative for interprocess communication. But the point is, we've had better alternatives since the 1970s or the 1960s. That's not the problem. There are lots of better alternatives. The problem is people don't know or care about the better alternatives. I went to a conference this past weekend about molecular simulation and nanotechnology kinds of things. And I gave a speech that I was not able to finish because they didn't give me enough time about how to make things go fast. And one of the things I did manage to get to say was like, here's why object-oriented programming makes your thing slow automatically. And then a dude later on who was demonstrating his, you know, running in the browser JavaScript framework for molecular simulation was like, and sorry, Jonathan, but you have to have virtual methods in order to have an open platform. So yeah, we do that. And then he was not even able to simulate a small number of, he had to like upload it to the cloud to simulate a small number of atoms in a cube. It was nutty. But like this dude literally said the sentence, he literally said, you have to have virtual methods in order to have an open platform. And this guy is writing software for scientists and advancing or preventing from advancing the progress in the field as the case may be. And this is just where people are at right now. They just don't understand, right? Their brain, like, they don't even say, wait a minute, when did virtual methods become a thing? And do I really think it's true that at no decade in history before that was there any kind of ability to coordinate on a standard of how to call functions? Like, really? Like, people don't even think that far. They just say, I have received the religion of virtual methods from the CS professor with the professor hat on, and therefore it is true. This guy was from Europe, so you know, that makes it extra bad. What does that even mean? Well, you could imagine what it means. Like, look, you can't have an open platform unless you can extend an object by declaring a new method override on the object, right? Obviously, that's how computers work. It was so stupid, dude. Like, and the fact that he name checked me specifically to say that was so, I didn't reply. I did not ask a question during the Q&A. Is kind of demoralizing that that's where the programmers who think they are the best say shit like that. So that's where we are at. That is where we are at. Okay, there's a couple things. If I can't really nap that well, which I probably can't, there's a couple more things that I can come back and do on the stream. I can document these little sample programs in the API a little better, and I can do the Linux port. Because the Linux port is not there. If we go to the module, oh, well, we have the file. Does it exist? Incomplete. That's the file, everybody. Congratulations. Did I put Ubuntu here? No. So I would have to do it on the laptop where you can't see anyway. Yeah. Anyway, but we could do that. It's 150 lines of Windows specifically. So, you know, probably about equivalent in the Linux land. In the Linux land. They explain object-oriented programming before pointers. Well, that's great. Was that a speech I've given before? No, and that's kind of why it was a drag, because I put on all this time and energy to like write a speech. It wasn't long. It was just 10 minutes, but it still takes a long time to try to do something good for 10 minutes when you don't know who you're talking to and stuff. And like, I didn't even get to finish it, so that sucked. It was sad. The languages you've seen, use of dynamic libraries seem extremely coupled to the C runtime and memory model. Is this intrinsic somehow to dynamic libraries, or is it a language issue? Okay, it depends on how you think about the computer. If you think about the computer, those dynamic libraries are a C language thing, then it makes sense not to support them necessarily. But the problem is that's not really what it is. What it is the operating system's interface for you know, being able to like load after you're running, for example, a plugin or something, functions that run natively and quickly, right? So nobody, like, there's no restriction, for example, in a dynamic library that it has to be a C program, right? It can be in another language, and it's just the calling convention is known and is what's in C. And so the correct understanding, now it gets a little bit muddled because on Unix systems, C was sort of the official programming language of Unix systems. And so there's a little bit more blurring of those lines. But like, that is the proper way to understand these things, is that it is the interface provided for coordinating between fast programs at known points of coordination. And so when people make, like, you know, JavaScript or, you know, whatever else, and they don't give you a way to interface with that, that has some historical roots. Like if you're sandboxing someone on the browser, you don't want to let them interface with that, right? But then once you're doing like React Native and shit on the desktop, React quote native unquote, like it's just silly at that point. Like you're running a lot slower than you should for no particularly good reason. And the problem is people don't even understand that that is what has happened. They just think, oh, you have to do this LSP thing in order for programs to talk to each other. Like as if programs haven't been talking to each other since the 1950s, right? in various different ways. Give the talk here after I nap. Well, I mean, I've sort of declared that I'm doing this weekend project, so I kind of want to save the energy for the weekend project. And the thing about the talk is I am not, like, for it to fit in approximately 10 minutes, I had to strip it down so far. Like, I don't think I'm going to end up saying anything that people haven't heard me say, like, a lot. Like, basically, if people were here for that call that I did with Casey when I was working on the slides, you know the talk. So, yeah. Anyway, so I'm going to go try to nap. It may be a long nap. It may be a short nap. It may not be a nap at all. But the plan is I'm going to stream a bunch more this weekend, unless I get super grumpy and decide to take it off the stream. But my plan right this second is I'm going to do a bunch of sub-only streams because I haven't done those in a long time. And they're more fun a little bit because it's a smaller crowd, right? And we're just going to keep going through this and do this piece of dramatically cool value for the people that they don't have in almost any other programming environment that they've ever seen, because that is what we are about here at Programming Language Laboratories. And if we don't happen to finish it this weekend, that'll be a little bit of a bummer, but I think it shouldn't be that hard, honestly. Like, I feel like just tomorrow we should be able to get it pretty good. Like the basic thing. And, you know, there'll be a bunch of rewrites of stuff that come later as I figure out how to do it better. But, you know, like the basic thing. And also just figuring out how to draw stuff better, maybe. Anyway, thanks everybody. See you later.